Hi everyone, my name is Dsouza. I'm part of the online content team of the Data Science Student Society here at UC San Diego. Today with me, I've got a very special guest, Professor Julian McAuley, who works at the Computer Science and Engineering Department. Professor, how are you doing today?
Great. How are you doing?
All good. Professor, you obviously are very heavily involved in this line of work known as recommender systems. Many people know you as a researcher, some people know you as a teacher. How would you introduce yourself to someone that works out of academia, and could you just give us a small brief about your research on a day-to-day basis?
Sure, yes. If I was talking to someone outside of academia, I would not talk about academia. I certainly wouldn't talk about machine learning and AI
Absolutely.
and all that horrible stuff that no one wants to hear about. I guess if you're asking about how I would describe my research, it's AI and machine learning and all that horrible stuff that no one wants to hear about. We've been doing recommender systems broadly writ the whole time I've been at UCSD, which is more than 10 years now, which used to mean the kind of algorithms behind, predicting your next click on Netflix or what products you'll buy on Amazon, all of those widgets you see that rank or list a bunch of items on a product's homepage. That's what recommender systems traditionally are. These days, most of the research interest or most of the funding is around recommender systems combined with large language models and conversational agents and things like that.
Definitely. It's definitely a very interesting field of work. And as someone that's taken a couple of machine learning classes, it definitely seems to be interesting, but kind of hard to get into, if you get what I mean. So what really was the pivot or the moment where you realized that this is what you wanted to get into in research?
Oh, I don't know. I guess that was a long journey. I took an AI class for the first time in, maybe 2005 as an undergrad. And it seemed fascinating. I think what was fascinating about it was, I liked that it involved a lot of mathematics at the time because I had been studying mathematics. I had an undergraduate degree in mathematics as well as computer science. So I was intrigued by this area of computer science, which seemed to be a lot more heavy in mathematics. And that, persuaded me to take a research internship one summer, and that persuaded me to get into a PhD. Back in those days, I was doing a very niche topic within computer vision, using a kind of machine learning called structured prediction or graphical models or something like that. All obsolete these days. This was kind of before the big deep learning boom that happened around 2010, 2011, which, I suppose rendered the content and the direction of my PhD pretty much completely obsolete, which is fine. A PhD is supposed to be something that's very deep on a research topic. But yeah, in the interest of getting a job and having a career, I had to do something different. So the hot thing at the time was social networks and social media and using machine learning to do predictive tasks on social media. It had maybe a surprising amount of overlap with the work I've been doing in computer vision because, I've been using all of these graphical models to understand relationships among objects in visual scenes. The same kinds of machine learning techniques seemed like they would be applicable to analyzing social networks. And so I sort of jumped ship into this hotter topic. And likewise, social media, social network analysis, that was its own trendy topic in machine learning research for several years. I'd say it's not on the way up anymore. But when I started as a professor, I sort of, again, moved on from that. I wanted to pick a research topic that would, be more sustainable for the length of one's career. So recommender systems is kind of adjacent to social media analysis. Social media analysis is about things like predicting friendships and social links and reciprocal communication and stuff like that. So interactions between people and people. Recommender systems is more about interactions between people and things, but methodologically very close to social network analysis. You're still analyzing these large, temporally evolving interaction graphs, if you like. But recommender systems was a sort of, perennial, I don't know if you know your plant words. There's always stuff to do. It's a research area that is not going to run out, I think, in a way that some of the topics I'd been working on before that had, partly because development of recommender systems requires a lot of what's called model parsimony. We have to have models that are very cheap, which don't have too many parameters, which means they have to be very carefully designed around every application. there's kind of no hope of getting this sort of God model the way people are trying to develop for natural language, where it's like, well, let's just build one huge, powerful, general purpose model that does everything. Not really the case with recommender systems. You have so many items, brand new items, so many users. You need the system to be so instantaneously reactive. You need models that are very cheap and very carefully designed around every single industrial application, which means there's kind of, always work to do, always, some amount of funding to be had for doing research in this space. So it was an area I was able to sustain a career in long term. I felt no need to move out of it, although, yeah, of course, the direction has changed. Now everything is about conversational agents, NLP, all that stuff.
For sure. I think just going back to what you said, especially when you were doing a PhD, a lot of what a new data scientist has to deal with is, okay, how much do I focus on theory versus how much should be applicable or useful in the real world? So when you're looking at something like recommender systems, back when you were doing a PhD, for instance, how relevant was it for you to do stuff that was actually tangible and useful in day-to-day situations?
Well, yeah. Times have changed since I was doing my PhD.
Definitely.
It's like more than 10 years ago, like I say. At the time, I would characterize a lot of the problems in machine learning as being less solved than they are now. I'm not to say that they're solved now, but there wasn't a single promising direction that everyone was pursuing in order to solve them. Many people were trying many different things. Trying something that, involved a different type of mathematics or optimization technique or something that other people didn't know was something very promising to try in a PhD in those days. So to the extent that you were, better at math than other people, that was a skill you could very easily leverage to write papers that other people couldn't write and write code that other people sort of couldn't write. So, yeah, that's the advice I have in the past given to lots of students is like, well, yeah, develop your theoretical knowledge, getting ahead in an area like machine learning, actually developing new machine learning techniques requires a lot of knowledge of mathematics, especially, optimization and calculus and so on and so forth. I'm more reluctant to give that advice these days. I think, right now we have more of a, research in machine learning is so expensive and there's so much investment in a single category of techniques. It's not quite as exploratory or maybe risk-taking as it used to be. And yeah, certainly the specific skills I developed, like being really good at optimization and writing tight C code to do gradient descent and all this calculus stuff, it's like, yeah, that's been rendered mostly obsolete by high-level programming languages and modern tooling. That, yeah, I would be hesitant to tell a junior student to pursue at least those areas of mathematics.
Definitely. So would you say we've sort of made progress in understanding these complex systems, or is it just that our modeling approaches sort of got better and, less drastic than it used to be back in the day?
I'd say our understanding has probably increased, but I think, yeah, the pace at which you can try out new models has increased drastically, and I think that's maybe a bigger part of it. Like I was sort of saying, the process of implementing a new machine learning model used to be extremely laborious. It would take months and months and months, and that would be the contribution of your paper. It's like, okay, I made some small change to the model. I computed all of my derivatives. I wrote some really tight parallel C code to actually make it work on whatever hardware I had at the time. It led to some small improvement. Nowadays, you can do that kind of thing instantly. You just write down the objective function you're trying to optimize, and you let a high-level optimization library kind of do everything on a powerful GPU. It allows you to experiment with a lot of models a lot more quickly. And that has helped people quickly converge to approaches that are reasonably effective.
Definitely. Was there anything interesting or shocking that you found in the recent past that you would not have expected, say, 10 or 20 years before?
10 or 20 years before, that's a long time ago.
Mm-hmm.
I certainly would not have anticipated the progress large language models would have made. I remember an anecdote from my AI classes when the professor was, talking about the grand challenge problems in machine learning. And, there were these simple, like, grammatical tests. What are they called? Winograd schema or something. They said, I was talking to my mother and my sister and I said that she had punched me. It's like, well, does the she refer to the mother or the sister? You know, it's sentences like that. It's like, well, okay, that's so impossible for a machine learning system to solve. It requires so much world knowledge, so much context. It really encapsulates what it means to have human intelligence. I remember the professor talking about like that Shakespeare sonnet. It's like, shall I compare thee to a summer's day? Why couldn't it be a autumn day? You know,
Definitely.
why would that change the poem? Like, you just couldn't conceive of a computer being able to solve that kind of problem. It's obviously wrong, right? You know, nowadays, or, you know, at the time we would have said, in order to solve that problem, you require true intelligence. You know, you will never solve that until you have solved AI, right? Seems to have been wrong, but I think, you know, it's also just an example of people moving the goalposts on what, like, artificial or true intelligence actually means. Like, we now view that kind of like English language proficiency test question as an easy problem in AI. We've moved the goalposts of what the hard AI problems might be. But yeah, I mean, if you took GPT-5 back 20 years ago, people would think, oh, okay, AI is just being solved.
For sure. Just to sort of add on to that, as a student in data science, so anyone that's in their early career, LLMs are scary. I'm pretty sure they're scary for you as well. So how are you sort of navigating this onset of LLMs? What do you think are the most relevant skills to have, skills that cannot be replaced by AI as easily as other skills?
Yeah, it's very hard to give good advice around that topic, and I'm kind of reluctant to do so. I think we're still in a transitionary phase where, what can I say? Maybe this sounds too harsh. Like some programmers who are graduating have stronger programming skills than an LLM.
Definitely.
And some do not. You should try to belong to the former category, right? Certainly when I look at like PhD students from the lab who graduate, you know, experts in large language modeling, you know, they've had more career success than ever since I've been advising. I mean, the salaries are so high. The job market for them is so hot because they're the people who can actually push this stuff and develop this stuff. So, you know, I would say fight the good fight. You can be a better programmer than an LLM. Like, aim high, and you do have to learn the skills. You're never going to get there by leaning too heavily on an LLM during your education, right? But yeah, like I say, I'm really reluctant to give that advice because it may be true on an extremely temporary horizon, and in 2 years it's like, well, sorry I said that.
Definitely.
It was all wrong. So yeah, I don't know. I think one mistake a lot of people make is, okay, they see an AI boom or they see an LLM boom, and they imagine, okay, well, I'm going to become, I don't know, LLM type tech bro or something. I'm going to get money from that boom. And I think that is a mistake people make. Like, everyone uses AI now. Everyone uses LLMs, not just in computer science, but all over the place. You would probably be better focusing your efforts on some application domain that you actually care about, get a job doing something valuable, rather than being too focused on the techniques. You know, I say this to PhD applicants a lot too, but also to more junior people. Like, I think just trying to be a good LLM person is maybe not a winning strategy, and maybe focus on, you know, healthcare or bioinformatics or an application domain you care about, in which, you know, LLM competencies or machine learning competency will be valued, but it's not the core competency of that discipline.
Definitely. I think I've read somewhere that LLMs are reflective of your own knowledge domain. So if you're an expert at something specific, you could actually use the LLM to your advantage to get insights that are more relevant to you. Is that true, given your research, or do you just think that's kind of just like a LinkedIn post?
It does sound a bit like a LinkedIn post. I mean, what can I say? I don't use LLMs. Maybe that's a hot take. But, you know, I don't use them to write code or to write my paper reviews. Lots of people, I'm sure, do. But, you know, certainly the uses I have heard are for, well, you know, the cases where I've occasionally touched an LLM and allowed my hands to get dirty. I mean, that's usually been extremely mundane stuff. where it's like, okay, I need to convert this unstructured text into a CSV and don't want to spend 20 minutes writing a Python script to do it, whatever. I would be extremely reluctant to use it in a way that actually interfaced with the areas I am expert in, and documents written by an LLM about my subject of expertise have so far not been very compelling.
Definitely.
And I think there's that phenomenon where it's like LLMs seem very intelligent, or even other people seem very intelligent until they're talking about the subject that you know intimately, and then you can see the weaknesses, and it makes you think, oh yes, actually maybe they're equally weak in all areas.
So do you think there's like a threshold until a certain point, and LLM is probably a good sort of partner to talk to or sort of exchange ideas with, but beyond a certain threshold, you are the expert? And
yeah, again, and maybe it's a hot take, but I don't touch the stuff.
That's
right?
good.
I mean, I do research in it, but I do. I mean, my students do research in it. I do not use an LLM. I mean, I don't want to. I don't feel I need to. I recognize that as a privilege.
Definitely.
I'm at a point in my career where I can just say, no, that's not.
It works.
Yeah, no, thanks.
Definitely.
I'm going to keep doing things the way I have been as an old man for the next 10 or 20 years, right? But for me, it's been a technology I prefer to avoid professionally and in my personal life.
Definitely. I think just to sort of shift the focus away from LLMs now, you are a piano player. I know you teach a course with machine learning and music. Can you tell us a bit more about how you got into that line of work and why it's relevant to you?
Sure, yeah. I mean, what can I say? It's a bit of fun. We do have several students in the lab who are doing research on music. I mean, I ended up advising a few students because I did have a machine learning lab, and I had an interest in music just as a hobbyist. So I ended up with a few students who were pursuing machine learning for music. And yeah, I mean, eventually we built kind of a group around that topic. So there's now several students in the lab doing music. And it's becoming a more, I don't know, it's respected the right word, discipline in machine learning, partly because it's sort of starting to work. And it made sense to teach a class around that. I mean, what can I say? Like, this is a research area that goes back since forever, right? I spent a lot of my class time talking about the history of this topic. People were trying to understand the so-called rules of music in order to compose music algorithmically, mostly without much success, right? It's very hard to do that. Mirrors the history of language model development pretty closely. People were trying to build language models by, understanding formal grammars and how to build parse trees, all that sort of Chomsky stuff, which did seem fairly promising, but I guess didn't end up being the winning strategy. Likewise for music. I mean, all of these systems that tried to understand music using formal grammars and rules from music theory, they didn't make much progress. And it would have been very hard to teach a class about that stuff because not many students in computer science know music theory, right? But one way or another, this field has been also upended by deep learning and generative models and large language models in particular, such that the winning strategy to generate music is to collect very large data sets, train large models on them, get them to generate some stuff without any built-in knowledge of music theory or maybe a little bit of understanding of how audio works. But yeah, that made it very feasible to teach a class on this stuff. And I think there is this future for music within computer science. Why shouldn't it have the same status as language or vision, right? I mean, no one says language or vision should belong to only the humanities or the arts or something, right? It's like those are proper parts, the significant parts of computer science. It's like, a third of the faculty or something is doing language or vision, but no one's doing music, right? Why not? It could be taken a little bit more seriously, and probably it will be in the future. Now that it's starting to work, now that you will start to see industrial applications that are worth a lot of money as well. Not that we've received any funding yet, but I think it's around the corner. It's on the way to being taken more seriously, and I think that's partly why there's lots of students taking these classes. But yeah, it's also just a bit of fun.
Just to add to that, I've noticed that on your website you maintain these sort of structured data sets. A lot of your work is open source. How important is sort of education, sharing your work, teaching to you? Because definitely for someone like me, at a very formative time in my career, people like you do have an influence in the way I look at data science. So how relevant or how important is that for you professionally?
That's pretty important professionally. I mean, I think it's one of those mundane things that has been largely responsible for the lab's success. I mean, we got a reputation for having lots of big data sets that people used,
Definitely.
at least within recommender systems, but also within other areas of research. You collect a new data set, you will often find that the methods everyone thinks work really well actually don't work that well once you apply them to a new data set.
For sure.
Which, okay, for one, it's valuable as it reveals weaknesses in the approaches people are currently developing. But secondly, it allows you to write a nice research paper. It's like, okay, we've seen that things don't work properly. We can now fix them. So as a PhD student, really, I mean, cynically, it was a strategy to get lots of papers accepted. Collect a new data set, show that existing methods don't work well on it. They never do because they were designed around whatever data sets were already popular. Come up with a method that fixes those problems and works for that new data set, release the data set so other people could use it. But in the end, like, those papers where we released data sets ended up being by far the lab's highest impact papers, and people did not necessarily care about the methods in those papers,
Definitely.
which were just, whatever random thing we were trying at the time. People cared about the data sets. So, all these papers that have the most citations in the lab or whatever, they're usually getting cited because of the data set. I think that is a big part of the appeal of an area like recommender systems as well, is so much of the data, at least that academics use, is sort of publicly available. It makes the pace of research extremely rapid. If you compare it to something like, I don't know, clinical machine learning, where data is and reproducibility is such a huge problem. Areas like recommender systems can move a lot more quickly. I mean, I think it's people would say, why are you, making some money for Jeff Bezos or something, like building these recommender systems rather than doing something useful. I mean, I think it's partly due to the frustration that it's actually hard to have high impact work, like high impact technical machine learning work in areas like clinical machine learning, just because of the slow pace and lack of reproducibility of the research. If you're trying to push ML methods, an area like recommender systems, where you can do everything on public data, release all of your code, is going to be an area you can be much more productive in. Of course, if you care about the applications of clinical machine learning, that's a different topic. But if your goal is to push ML methods, reproducibility is extremely important. It's also something very mundane. I mean, I just found that I wasn't really competing with anyone by collecting and releasing these data sets. It is a specific skill. I mean, it's a sketchy skill. You're just, building web scrapers and getting around captures and all that stuff. But it's a skill, and it's laborious and it's boring, and then you've got to maintain the data set afterwards. So I didn't think it was very hard to do, but I kind of realized that nobody wanted to do it. Even my students often don't want to do it. I'm like, you want to study this problem, the first thing you should do is spend 6 months collecting a big data set. It doesn't excite people, but it certainly was an avenue I could use to carve out a niche. Sorry to mix metaphors that other people were not getting into.
Definitely. So, Professor, it's a rapid fire round. We just do a quick couple of questions. Just pick the first thing that comes to your mind. Select between the two. Tea or coffee?
Coffee.
Do you like the indoors or the outdoors?
I suppose in theory the outdoors, but in practice the indoors.
Mm-hmm. If you had to choose for the rest of your life only to work on research or to be an instructor and teach, what would you pick?
Goodness. I'm going to say research.
Mm-hmm. For sure. What would you say was more foundational for you, linear algebra or probability?
Linear algebra.
And finally, if you had to choose not to work in recommender systems for the rest of your life, or not to ever have a can of beer, what would you do?
Goodness. I think it depends what else I'm doing instead of working in recommender systems. I'm not particularly into beer, but I think one could, just not working for the rest of one's life sounds okay too.
Definitely. I thought you actually worked a lot in your early years in sort of working with beer data sets.
I did. It does not mean I'm particularly a drinker.
Oh, okay, for sure.
I have a pretty tough time with beer, especially since reaching middle age.
Definitely, for sure. Mm-hmm.
Yes, I have some very fond memories of drinking a beer, but it doesn't enter into my life much anymore.
And finally, San Diego or back home in Australia?
I guess back home in Australia.
For
sorry.
Sure. Mm-hmm.
It's all right here.
Uh-huh. And just to sort of close off, sort of a forward-looking question, if you had to look at an area that's sort of untapped or not really explored in machine learning, what would you say that is? And when do you think it's going to sort of blow up?
Well, yeah, I mean, what can I say? I mean, I think that's what music for machine learning kind of is, not to
For
call
sure.
it untapped, but, I think
Mhm.
it's a little bit tapped. There's lots of specific areas within machine learning for music that haven't really been explored. Lots of problems that have not been solved. Like we don't really even know how to properly represent music in a way that it is digestible to language models. I mean, I'm more excited about that research area, partly because there isn't this sort of monoculture around research techniques. Like we still don't know what works, and that's what makes it a lot more fun in a way.
Definitely. I think that was all we had, Professor. Any parting advice, any last words that you'd like to share?
No. I mean, mostly I do tell people like
Mhm.
get advice from someone younger than me. An academic who sits in their office all day is not always the best person to give
For
career,
sure.
even though their career may have been successful.
Mhm.
Their career advice is sometimes not as relevant as your your peers who are maybe very slightly more senior than you.
For sure. Thank you so much, Professor.
Yeah, cheers.